Hello, good morning, afternoon, the usual. Welcome to our Unit 2 review for our finals. Basically we just have a series of let me model one and kind of work through it, and then you're going to try for a couple key things that are going to be important to know going into finals. If you need to pause me or whatever at any point, again, as always, feel free to do so. So the first thing we're going to look at is evaluating functions with graphs or tables. If you were in class, we did a little re-intro to this in our Pear Deck. But let's go ahead and get started. So we have use the functions above to answer the following questions. What is f of 2? Now, I have two different functions here. I have one of f of x and one of g of x. So that f tells me that I am looking at my graph. Ooh, I should have done that with red. So that f tells me I'm looking at the graph here. And then it says f of 2. So this is saying when x is 2, what is the value of y? So I'm going to look and find when x is 2, which is right here. And my y value at that point is 3. So the answer for that one is 3. The next problem is what is x when g of x equals 10? So I'm asking you for x, and now we're looking at g of x. So now we're looking at this function, and I want to know when g of x is 10, x is 2. So we're looking right here, and at that point, x was 2. Okay, now I say how much greater is f of negative 2 than g of negative 2? So this means I'm going to look at when x is negative 2 on both functions, and then compare which one is greater and by how much. So f of negative 2, function f, negative 2 is 3. So f of negative 2, I'm going to just write it underneath it, is 3. G of negative 2, again that means x is negative 2, and the answer was negative 2. So, negative 2, ooh, I actually have this worded backwards. It is g of negative 2 is greater than f of negative 2 by 1, because negative 2 is bigger than negative 3 by 1 value. Okay, then we have which function, f of x or g of x, is increasing faster between negative 4 and negative 2. So this is saying between the x values of negative 4 and negative 2, which one is going faster, increasing the most, the quickest. So negative 4 to negative 2. I'm going to erase all of this stuff now. So we're looking from negative 4 to negative 2. My y values went from being 0 to 3 during that time. So it increased by 3. If we look now on g of x from negative 4 to 2, we increased by 6. Negative 8 to negative 2 is by 6. So g of x increased faster. Alright, so there is that model. I want you now to go ahead and try this next one here and use what we just did as a reference and see if you can figure it out, and then unpause me when you're ready to check your answers. Alright, so our answer for the first one, what is x when f of x is 2? You could have two answers. When y is 2, it can either be 1 or it can be negative 3. For the next one, g of x is 6. We get 0. G of 1 is 18. F of 1 was 2, so it's greater than that by 16. And then which one is increasing faster from negative 3 to 1? So we were looking from negative 3 to 1. And my graph was at 2 and then ended at 2. So this one increased by 0. Between negative 3 and 1, my table increased by 18. So g of x increased faster. Alright, let's go on to the next one. So now we are evaluating functions again. So just a reminder here, when we have a number inside the parentheses, that means x is that value, and we need to solve for y. So if I give you a function, g of x is 12x, find g of 2, I'm asking you, what is it when x is 2? So I'm going to take that 2 and plug it in. And my answer is 24. For the next one, find if f of x is 2x minus 3, find f of negative 2. Again, we plug negative 2 in. Multiply first, and we get negative 7. All right, go ahead and try this one. Pause me, and then come back when you're ready. All right, hopefully you gave it a try. So again, this means x is 7, so we're going to plug that 7 in for x. We do 5 times 7 minus 3. We get 35 minus 3, which equals 32. All right, we're going to get a little bit harder now. Stepping it up a notch, we have if f of x equals this and g of x equals this, what is f of 4 times g of 4? So this just means we need to first find what f of 4 is. So I'm going to say 1. Let's find f of 4. So my function was 2x minus 3. And then just like above, this means x is 4. So I just have to plug that into the right function. The f tells me we're going into function f of x. So we're going to do 2 times 4 minus 3. 8 minus 3, and we get 5 for f of x. Now let's do the next one. So now I say, now we need to find g of 4, and we have to plug that into our g function. So negative 3x plus 7. So we do negative 3 times 4 plus 7, negative 12 plus 7, and that gives us negative 5. And then now, the final question here was, what is f of 4 times g of 4? So to end this, we multiply the two together. 5 times negative 5. And we get negative 25. Okay, now I want you to pause me and try this one. I know I'm doing it quickly. But again, same thing as above, you're just doing 2 and 1 and then multiplying your two answers together. So f of 2, you plug it into function f. G of 2, plug it into function g, multiply your two answers together. All right, pause me, give it a whirl, come back when you're ready. All right, so the answer was negative 8. So we took that 2, undo that. We took that 2 and we plugged it into our function, my f function, and then we get 8. And then we did the same thing but with my g function, where we plugged 2 into my g1 for x, and we get negative 1. Multiply those and we get negative 8. Try again if you got it wrong. Pause me if you got it wrong, see where you messed up, and fix your answer. All right, the next one is an interpreting graphs section where I give you a story and I want you to go ahead and choose which graph represents this. Pause me now and I want you to try this one on your own first. We did really well with interpreting graphs, so I want you to give this a shot first before I give you the answer. All right, see you in a second. All right, so let's break this up one chunk at a time here. The first one is Brandon walks from his classroom from his commons area to the class at the other end of the building. So all of these, the distance should be increasing, and you can see it is, right? We're increasing, 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 meaning we're getting further away. So all of those, we're off to a strong start. Next one, we go, he got to math class and sat in for an hour. So that means he's not moving. He was on a break. Not moving means we should see a flat line. A and C give me the flat line, whereas B tells me he turned around and walked back for some reason. He did not sit for an hour and do nothing. So it can't be B. And then the last part of this, we have after class he headed back to the commons, so my distance should go down. He stopped to fill up his water bottle and then finished walking. So our distance should be going down first, going down, but then he stopped to fill up his water. So that's a point where he's not moving. This one he continued walking. This is the only one where it gets that flat part again, which that represents him filling up his water and then walking back to class. So the answer for this one was C. All right. Next up, what is a function and creating an ordered pair to either keep it a function or make it not a function. So we have this relation below right now is a function. Remember, a function means each input has one output. So right now, -2 only has one thing out, a 5. 0 has one thing out, a 3. 1 has one thing coming out, a 10. So this one is currently a function. I want to write one additional coordinate that would ensure this relation is still a function. So to an ordered pair that would keep this a function, we can just repeat any one of these. So I could say 7, 3, because that's already an ordered pair here. 7 is giving me out a 3. By listing that, I have the input of 7, but it's giving me out the same thing. So you could repeat any of those points given to keep it a function. You could say 0, 3. You could say -2, 5. Repeating any of those keeps it a function because that one input is giving you the same thing out. Now write one additional to make it a non-function, meaning one of your inputs is giving you something else out. So you could say -2 and then 10. So I picked one of my x values that were already being used. Originally it was giving me out a 5, now it's giving me out a 10. -2 is giving me two different things, not a function. Or you could change 0 and say 0 and 100. Originally 0 gave me out a 3, now 0 is giving me out of something else. So to keep a function, repeat any of these. To make it not a function, you want to keep your x value the same, but change your y value. All right, try the one right next to it and then come back and check your answer. All right. So which point would keep it a function? Again, repeating any of the points given there keeps it a function. So any of these 4 points that you see from the table. And then which would make it not a function? 3 and then anything but 11, the one it came with. 5 and then anything but 12. 7 and then any number but 13. And then 9 and then any number but 14 would be your answer for that. All right, last step here, again, pause me if you need to go back and finish that, is something linear. So again, when we determine if something is linear, we are just finding the rate of change over multiple points, finding the slope, or the change in y or the change in x over multiple points. And I'm going to try and show you a little bit of a quicker way. So again, we can tell how to tell if it's linear. We can tell it's linear by finding the change in y over change in x for multiple pairs and see if the number is the same. If we have the same rate of change each time, that means it's linear. So we do this, if you remember, by drawing our arrows, and then we find the change in y. From 5 to 8, we add 3. From 2 to 3, we add 1. And then we write it as y over x. So 3 over 1. Which equals 3. And then we do the same thing here. 8 to 11 is plus 3. 3 to 5 is plus 2. We write it as y over x. We get 3 over 2. Whoop. So this would not be linear because my rates of change are different. About to be out of time, so this was not linear because they were different. The middle one is linear because the rates of change are the same, and the bottom one is no because the rates of change are different.